So here it says two springs A and B are connected in parallel. They are subject to a weight of 5 newtons, as a spring A has a spring constant of 25 newtons per meter, and then spring B has a different spring constant of 50 newtons per meter. So spring A is on the left in the diagram, spring B is on the right. Part A asks us to find the extension each spring. Part B asks us to find the force experienced by spring A. And then part C asks us to find the force experienced by spring B. All right, so let's crack it out. I'm going to go ahead and label the spring constant for A and B because it's given in the statement. So here is the spring constant for spring A, which is 25 newtons per meter. And then spring B has a constant of 50 newtons per meter. So spring B here is a little stiffer. And then the weight of the system that's pulling down on these two springs hooked up in parallel is 5 newtons as shown in the diagram. All right, let's go and crack out part A. To do part A, all you have to do is really apply Hooke's law. Hooke's law here says the force of the spring is equal to negative kx. And this is generic. This can be applied across the board. All right. In order to find x, I have to divide both sides by negative k. So here we have the spring force divided by the spring constant, which is equal to the extension of the spring system. All right, but to do so, this you're not presented with a single spring here. You have two springs that are hooked up in parallel, right? So in order to do this correctly, you have to find the K effective of these two springs in parallel. Well, to find what the K effective is for a series of springs in parallel, all you have to do is take the springs constant and add them. Spring constant A plus spring constant B. All right, and therefore to do so, all I have to do is plug in values for Ka. Ka is given as 25, and then Kb is given as 50. So the effective spring constant here is simply 75 newtons per meter. Well, now that I have the effective spring constant, I can just apply it in Hooke's law for this particular system. All right, once again, Hooke's law is generic, and you have to make sure you apply it correctly. Well, I know what the spring force is going to be, right? The spring force is going to be 5 newtons. Why? Because that's the weight of the system that's pulling down on it. Okay? Therefore, this effective K constant here that I highlighted in yellow is 75 newtons per meter. So if you take the 5 newtons, the load that's given in the system here, divided by the effective spring constant, which is 75 newtons per meter, with that I just added these two constants together for a parallel system, you're going to get an extension of negative 1 over 15. I just reduced 5 over 75 to 1 over 15. And if you don't like fractions, you can convert it to about 0.06666. It's like running on. So I just ran up to about 0.0667 meters. Okay, so that is our answer for part A. So given the system, if you were to hook up a 5 Newton weight or load, it will stretch the system by 0.0667. All right. Well, if that's the case, to do part B and C, it says find the force experienced by by spring A. Well, to do that, we just have to apply again Hooke's law for just spring A. So you notice here I have force of spring A equals negative Ka times x. Well, we know what Ka is. Ka is given as 25 here newtons per meter, and then we just found the extension in the system, which is 1 over 15, or you can use this decimal if you like, right? 1 over 15 is just a bit more accurate, but it doesn't really matter. It's up to you. Here, a negative carry sign carries down. Ka is given as 25, and then x here is negative because it's being stretched downward, 1 over 15 meters. And if you simplify this, you'll get 25 times 1, which is 25, and then 15 on the bottom says 15. The two negative signs multiplied together will make it a positive, which makes sense because if the load is pulling downward, the spring the spring force has to pull upward, right? It acts against what the system is trying to do. Therefore, if you reduce 25 over 15, you get 5 over 3. And if you want to convert that to decimal, that's up to you. If you want to leave it in fraction, 5 over 3, or you can round it up to about 1.666666 or 1.667 here in newtons. So that is your answer for part B. Likewise for part C, to find the spring force experienced by spring B, all you have to do is really do the same process, except here we just have to do Kb, the spring constant for spring B, and the extension is the same because in a parallel, if one spring stretches by one amount, the other spring stretches by the same identical amount. So therefore, spring constant B is given as 50 newtons per meter. Once again, the calculated x value here in part A is negative 1 over 15, which is what I'm circling in the on the towards the mid screen here. And then if you wanted to, you can use the decimal version, but I'm just going to use the fraction version just because it gives me a more accurate value. Here, negative times make it a positive, so really 50 times 1 is just 50, and then the 15 in the denominator is 15. So here, if you want to, you can reduce 50 divided by 15 to 10 over 3. And if you want to, you can further reduce it to just 3.333 newtons. All right. Other than that, that is the answer for part B and C. All right. So you have A, B, and C. All right. Stay nerdy. Don't be what?